Have you ever thought about an AI having, well, an allergic reaction? Not to something like pollen, but to people, or ideas, or even entire cultures that it sees as foreign. It honestly sounds like something straight out of science fiction, but it's a very, very real problem happening right now. Let's get into what that really means.
So there's actually a name for this, Xenoreactivity. You can think of it like a bug, but not just a technical one. It's a socio-technical problem. This is what happens when an AI, this tool we expect to be completely objective, starts to show bias. It reacts negatively to anything or anyone that falls outside of its very limited digital comfort zone. It's a glitch in the machine, for sure, but with huge social consequences.
And that brings up the million-dollar question, doesn't it? How on earth does a system that we designed to be intelligent end up learning something as flawed as prejudice? Well, it doesn't just happen overnight. This is a story that has a beginning, a middle, and an end, and it all starts with the ingredients.
Right. So bias doesn't just appear out of thin air. It's not magic. To really get this, you've got to go all the way back to the start, to the absolutely massive oceans of data that these models are trained on. This is ground zero. This is where the first seeds of unfairness are planted.
And this is where you can really see how it works. The AI models, they develop a kind of preference for the data they see over and over and over again. That's the in-group data. They get really good at it, process it with high confidence, but the moment they see something new, something foreign, or from an out-group, they treat it like an anomaly. Their confidence drops, and that's when you get errors or even these negative reactions. For example, if an AI only ever sees pictures of Western weddings, it might totally misclassify a beautiful traditional Indian wedding, not because it's wrong, but just because it's different from the norm it was taught.
And this kind of unfamiliar data, some people actually call it weird data. It's anything that's culturally specific or just different from the stuff that model was trained on. And when the AI runs into this, its programming can just kind of break. As the source material says, this data becomes a trigger for fallbacks and human escalation. In other words, the machine fails, and a person has to jump in to fix the mess.
And look, this isn't some random accident. This bias is often baked in from the very start. It's directly linked to where the data came from, what the experts call its provenance. You really have to ask the hard questions. Who put this data set together? Who was paid to label all those millions of images and text files? And whose version of history, whose values, are being presented as the default normal way of things? The answers to those questions, that's the real origin of the unfairness.
This all leads to a really powerful and frankly dangerous form of bias, cultural bias. The source has this amazing phrase for it, epistemic hegemony encoded as technical error. Now, that's a mouthful, I know, but it's really just a fancy way of saying that one culture's way of seeing the world gets programmed in as the only correct way, and every other perspective, it just gets treated like a mistake, an error to be fixed.
Okay, so we've got biased ingredients. What happens next? Let's move to the next stage of this whole process, the learning. This is where the AI model takes all that biased data and starts to internalize it. And this is where a simple data problem becomes a deep-seated programming problem.
And what you get is what we call learned bias. The prejudice isn't just hanging out in the data anymore. At this point, it is fundamentally baked into the model's core programming. It's like it becomes part of the AI's digital DNA. And that means you can't just put a filter on the end and hope for the best. The bias is now part of how the AI thinks. Getting it out requires major surgery, like retraining the entire system from the ground up.
One of the main ways this learned bias pops up is through stereotyping. The AI learns that using generalizations is a useful shortcut. It helps it make predictions faster. But this predictive shorthand, as the source brilliantly calls it, comes with a really steep moral cost. It reduces complex, real people down to simplistic and often very harmful labels. And it doesn't stop there. The model also learns how to do something called othering. It uses language and the way it represents things to create distance, to digitally mark certain groups of people as different, as alien, as outside the norm. For example, a language model might learn to associate words like CEO or doctor with one demographic and words like receptionist with another. This isn't just a simple mistake. It is, as our source says, semantic exclusion inscribed in models. It's literally writing exclusion right into the code.
So, we've got biased data that creates a biased model, but so what? Why does this actually matter out here in the real world? Well, this is where the theoretical problem crashes into reality and becomes a tangible, high-stakes crisis. The consequences, the negative yields, are just massive. We're talking about systems that can reinforce existing social inequalities.
systems that can literally lock people out of opportunities and amplify the struggles of already marginalized communities. This kind of thing completely erodes public trust, and it can even land companies in serious legal trouble.
And this quote just nails it. This is what we're talking about when we say unfairness. It's not just a vague feeling. It is a measurable misalignment between what the AI system is doing and what we as a society expect and, frankly, demand from a system that's supposed to be just.
And this unfairness can quickly escalate into full-blown discrimination, which is defined right here as actionable inequity. The key word there is actionable. It means you can actually do something about it legally, and it's measurable. You can look for disparate impact, which means the outcomes are unfair, or for disparate treatment, where the process itself is biased against a certain group from the get-go.
Okay, so this sounds pretty bleak, I know. It's a serious problem, but it's not hopeless. The good news is just like bias can be engineered into a system, fairness can be engineered back in. There is a path forward here. There are ways to mitigate this xenoreactivity.
The big takeaway here is that you need a holistic approach. You can't just put a Band-Aid on it and call it a day. As this table shows, you have to intervene at every single layer of the AI lifecycle. It starts with fixing the data, then building fairness right into the model's goals, and then running tough audits before it ever sees the light of day. Every single step matters.
You can basically boil this whole mitigation strategy down into 3 main phases. First, there's pre-processing. That's where you clean up the data before you even start training. Then, in-processing, where you actually change how the model learns, telling it to prioritize fairness. And finally, post-processing, where you adjust the model's final outputs to correct for any bias that's still left.
But even with all of those fixes, sometimes you're just putting patches on a fundamentally broken foundation. And that brings us to this really radical and I think powerful idea, zero-based thinking. The idea here is, instead of trying to fix a bias system that already exists, what if you just rebuilt it from the ground up, with fairness and inclusion as the core design principles from the very first line of code?
And that really leaves us with one final, and I think, crucial question. As we build the future of intelligence, is it really enough for us to just keep patching up the biases from our past? Or are we brave enough to wipe the slate clean and build systems that are truly designed for fairness from the very beginning? That's a choice that's going to define the next generation of AI.